Okay, so as mentioned, I plan to talk about open science and the PID Graph this morning, and a bit of the work that we're doing at DataCite in this regard. So to start, I wanted to share first a bit about open science, as open science in its own sake has never been the ultimate goal. This has really been for us as a community to embed open science practices into our workflows as part of a larger, more systemic effort to foster all practices and processes that enable the creation, contribution, discovery, and reuse of research knowledge more reliably and effectively and equitably. So moving into a bit of the work that we do as a community and at DataCite, one of the key things that we do is form collaboration and partnership with other infrastructure providers. And as many of you may know, Japan Link Center, DataCite, and Crossref are all registration agencies with the DOI Foundation. DataCite work very closely with Japan Link Center and Crossref. Japan Link Center is a member of both DataCite and Crossref to support the workflows for their members. DataCite has had a long-standing relationship with the Japan Link Center and continue to work collaboratively with our respective members, and together as key stakeholders in the scholarly infrastructure community, we support interoperability across persistent identifier infrastructure. It's critical that libraries, research institutions, and data centers that house and manage repositories have a voice in the decisions and are able to receive the optimal services and support. As such, DataCite is a member organization that provides DOI registration services and research infrastructure for this research community. And our community is a core to everything we do. So it's really important for us to listen and engage with the community and establish services that meet their needs. Our community, very briefly, DataCite has 33 consortia globally. We have just under 2,200 repositories with 238 organizational members, over 600 consortium organizations, over 20 million DOIs, and our members are spread across 43 countries globally. Our core activity at DataCite is providing tools for DOI and metadata registration. DOIs are registered for content that is hosted in repositories. In some cases, this is journals or other containers of information for hosting content. And therefore, there is an important relationship between the content, whether it be a data set, a text document, a sample, and the repository. And this is important as we start to establish the PID graph and the broader infrastructure. Importantly, when we talk about persistent identifiers, it's really important that we do not focus exclusively on persistent identifiers. This is something that I hear time and time again, that persistent identifiers are what we need. But it's really important to emphasize that metadata and the services associated with persistent identifiers are more important than just persistent identifiers in their own right. We should coordinate with the broader persistent identifier ecosystem to ensure that there are relationships between the metadata that we have associated with the persistent identifiers. In order to make persistent identifiers fair, this is crucial. Persistent identifiers, therefore, will continue to play an essential component for the implementation of the FAIR principles. And I'm sure many of you are familiar with the FAIR principles. The first is findable, so using standardized metadata, connecting persistent identifiers, make research data findable. The second is making objects accessible. So resolvable worldwide with every internet browser, the URL associated with the DOI can be updated and the DOI remains unchanged. making objects interoperable, so using standard vocabularies and links to other persistent identifiers, for example, software DOIs, instrument DOIs, ORCIDs in the metadata record of a persistent identifier, etc. And finally, reusable, so making sure that members in the community, researchers, can cite sources with confidence and receive proper credit for the work that has been done and reused, providing rich, up-to-date metadata that generates trust and linking to other persistent identifiers. So, as I mentioned, I want to talk about the persistent identifier graph, the PID graph as we call it. DataCite continued to work on connecting existing persistent identifiers to each other in standardized ways. For example, the outputs associated with a particular researcher, repository, institution, or funder for discovery and impact assessment. To address these use cases, we need a more complex model to describe the resources that are identified by persistent identifiers and the connections between them, a graph. In theory, this graph, the resources identified by persistent identifiers correspond to the nodes in this graph, and the connections between persistent identifiers correspond to the edges. Typically, we focus on people, places, and things. The DataCite metadata schema supports linking people, places, and things using these identifiers. The API that powers the PID graph, the graph formed by scholarly resources described by persistent identifiers, and the connections between the fair digital objects. The technology that we have used is powered by GraphQL, which is a widely adopted open source technology that enables queries of this graph, addressing use cases of our community in ways that were not possible before. And in a moment, I will show you some examples of this. The primary identifiers that we have started to use in the PID graph, and I should maybe mention that this is still in its early stages and we have lots of work to do with the PID graph, but the primary identifiers are the raw identifier for organizational identifiers, ORCID IDs for individuals, and digital object identifiers, DOIs, for things. Research, as we know it, is already a graph. Researchers, institutions, publications, datasets, and more are interconnected. Entities and the relationships between them form a conceptual graph of the connected research landscape. And as an example, on the right-hand side here, you can see different connections and relationships when we initially set up the PID graph and launched this. It could look like this. So we could have an institution, affiliations with authors, authorship with publications, input from datasets, reuse of software that is linked to other publications, to other authors, and funding. And so we can begin to map out the relationships between these different object identifiers. Persistent identifiers are the backbone of connected research. Having unique persistent identifiers for researchers and their outputs is crucial to connecting pieces of the research landscape together. Persistent identifiers already have the potential to enable connected research graph, but we're not yet taking full advantage of the connecting powers between these objects. So this is where we came up with the idea of the PID graph. We can link persistent identifiers together via relations in their metadata to enable the discovery of connections at least 2 hops away. So typically we know this relation from the metadata, that this object is related to B. So example, this author produced this data set. But sometimes we don't know that this data set is related to this article. And so by building the PID graph, it's possible to start understanding the relationship that is 2 hops away and further. The DataCite GraphQL has been the most convenient way to consume the PID graph with the DataCite metadata as the starting point. GraphQL is a query language that was specifically built for graphs. It lets you specify exactly what information you want and what structure you want to receive that information. And so the possibilities with GraphQL are almost endless. The DataCite GraphQL API is currently in pre-release with a stable release planned. Apologies, this was slightly outdated. It was released in March. We now have a stable version of the GraphQL API that has been launched. As an example, we have the GraphQL Playgrounds. So if you go to api.datacite.org/GraphQL, you can see here where you are able to specify what information you want and what format you want to receive this. And it gives you an example of the GraphQL. So it's really easy and possible for you to go and test this and use the playgrounds to test different use cases. Surfacing connections, so Graph, all the publications associated with DataCite, plus all the researchers and organizations associated with those publications. And so this was a specific use case that we wanted to solve at DataCite. And so we wanted to use the graph to answer the question, with whom has DataCite collaborated on their publications? So when we do that, we can go into the GraphQL API. We can select an organization ID, so put in a specific raw ID. We can then say we want the name, we want the data set, we want the total count, and any nodes that we want to specifically identify out of the graph, so perhaps identifiers and titles. So it's very simple and easy to use and allows us to really understand what can be done with the GraphQL API. We've now launched DataCite Commons, which is an interface that is built on top of the Pid Graph. This was launched as an MVP, a minimal viable product, 2 months ago, and we will be launching a production version at the end of this week. One example of this is if we use Tokyo Institute of Technology, it's possible to search for them via the raw ID. It pulls up all the other related organizational identifiers and then displays the related information with the institution. What is powerful about this is that it is possible to do one single API query to generate all of this information. The PIDs and the relationships, so we typically look at citations and references. And so typical citations are, if it's referenced by, it's cited by, it's supplement to, so a data set to a publication. We could also have experiments or articles that reference and cite and that are supplemented by data sets. And we also then have references and then other relation types that we have structured into our metadata schema. And these are really important because not only are we able to then identify relationships between different objects, but we also understand the nature of that relationship between those objects to deduce more information from the Pid Graph. So one thing that we have done is now being able to identify citations and usage. So in addition to looking at the relationships, we are also able to collect views and downloads and usage of the information on particular objects. And a lot of this work has come out of a project that we have been involved in, Make Data Count, which enables us to, or enables the community to add information to the infrastructure so that we can make this available openly to the community. We also can look at creators within the different objects. So this is an example of a specific article, and we can see the creators and their affiliations associated with them. We can see the views and the downloads in the specific object. Metadata, as I mentioned, is key to improve the reuse and discovery. A couple things that we've also included in our metadata schema to make it more useful to the community. The first is rights. So the rights field is where you can include information about the data's content license. As an example, CC0. When this information is in the metadata for the dataset, it helps researchers to quickly see at a glance whether the data being described is something that they will be able to use. This information is also important for harvesters, so systems that are gathering information from the API and trying to assemble lists of readily available data sets for researchers to use. The description field may at first seem not particularly critical, but abstracts and other descriptive information are often mined for emerging trends. And so in this case, like the current epidemic where COVID-19 might be a typical controlled vocabulary term, it may be possible to surface articles on this topic by mining abstracts. Note that our schema documentation also recommends providing an English language abstract to enable a wider dissemination where possible. The third addition is the related identifier, and this almost goes without saying. These are always important for linking resources together. And so this information that DataCite uses for our citation counts and to feed the PID graph, having this related identifier information is also helpful for following a trail of research from datasets to articles, to authors, to institutions, and so on. And finally, the subject field. The subject field is where you can include information about the subjects that are relevant for the item that the DOI points to. Under the current implementation of the DataCite metadata schema, this field is free text, so you can add any words that may be relevant to the item, whether or not they're part of a controlled vocabulary. If you would like to follow a scheme of vocabulary, you're not restricted to the subject scheme, you can specify. It can be helpful to comply with community-specific standards such as MESH, subject standards for medical topics, or DFG subjects for German-funded research, as an example. And finally, I started by mentioning that communities of practice are incredibly important for us at DataCite. And so collectively, I mentioned our partnership with Japan Link Center, but collectively as a global community, as an open science community, it's really important to work together. And establishing a community of practice requires three different aspects. The first is a common domain, and our common domain is connecting research together, identifying knowledge. We then need a common community, and together as a global research community, we form a community with the same ambitions and same goals. And collectively, we work together in our practice. Our practice is persistent identifiers for research, connecting persistent identifiers and the related metadata with the broader research ecosystem, and in allowing for us to embed open science in our workflows to ensure that we can create, find, cite, connect, and reuse research. The PID graph in open science enables processes that allow for the creation, contribution, discovery, and reuse of research information more reliably, effectively, and equitably. Together as a community, we can further our open science efforts. Finally, please get involved. We are an active community, and we love hearing from different community members that are using some of our resources. We have our email, info@datacite.org. Alternatively, please contact JELC, who work very closely with us, and other related colleagues from JST, try our PID graph. The playground is available. There is documentation available online. And finally, we have a forum, the Pid Forum, which is available and open to anyone. And this specific link here would take you to the forum that is available to the PID graph. And with that, I would like to end with saying building communities together. It's what we are incredibly passionate and interested in, and really look forward to working with you all. Thank you very much for your time, and I really appreciate the invitation.